Hi everyone. Today we will see Cambridge IGCSE Physics Paper 4 Theory Extended. This is May June 2023 Variant 4.1. Question number 1. The figure 1.1 shows a straight section of river where the water is flowing from right to left at a speed of 0.54 meter per second. A swimmer starts at point P and swims at a constant speed of 0.72 meter per second relative to the water at right angles to the current. Determine relative to the river bank both the magnitude and direction of swimmer's velocity. So here we can see he is swimming in this direction. It is right angle with the current, and the resultant force we can draw from the head of this one vector to the tail of another vector. This will be the resultant force. And for finding the resultant vector R, we can use the Pythagoras theorem. That is, R will be equal to square root of 0.54 square plus 0.72 whole square meter square plus meter square second square. So that is resultant force. This will be equal to one side it is 0.72 and one side it is 0.54. So R square is equal to 0.54 square plus 0.72 square. So R will be equal to square root of 0.54 square plus 0.72 square. While calculating 0.54 square, that is 0.2916 plus 0.72 square, that is 0.5184 meter square per second square. So while adding, you will be getting square root of 0.81 meter square per second square. After taking square root of 0.81, it will be 0.9 meter per second. So the magnitude of velocity will be equal to 0.9 meter per second. What about the direction? For finding the direction, we can use tan theta. So tan theta will be equal to this angle we need to take theta, that is opposite side by adjacent side. So opposite side it was 0.72 by 0.54. This will be equal to 1.333. So theta can be written as tan inverse of 1.333. Just we can calculate it. 1.333 tan inverse, that is equal to in degrees. So that is 53 degrees. So theta is 53 degree. Next, after 1.5 minutes, the swimmer reaches a point Q. Calculate the distance between P and Q. So time is T is given as 1.5 minutes. Distance can be written as D is equal to V into T. So the resultant velocity or speed is, the resultant speed is 0.9. So the speed can be written as 0.9. So he is swimming. So after 1.5 minutes, he is reaching Q. So what is the distance we need to find? So speed into time is 1.5 minute. It is, we need to convert to second because our velocity or speed is in the unit of second. So 1.5 into 60. So just we can multiply it. We'll be getting the answer 81 meter. Distance is 81 meter. As the swimmer is crossing the river, his actions produce a constant force on his body. Explain why he moves in the constant speed. As the resultant force is zero, he moves at a constant speed. Here, the forward force and the frictional force gets cancelled each other. He is moving in one direction and that forward force and the frictional force that is getting cancelled. That's why resultant force is zero and he is moving in a constant speed. Question number 2. Figure shows a motorcyclist accelerating along a straight horizontal section of the track. We can see a bend at this portion. The motorcyclist and the motorcycle have the combined mass of 240 kilogram. So here the mass is 240 kilogram combined mass. On the straight horizontal section of the track, the motorcyclist accelerates from rest at 7.2 meter per second square. So acceleration is given as 7.2 meter per second square. The motorcyclist reaches the end of a straight section at 5.3 seconds. So he reaches here at 5.3 seconds. Calculate the speed of the motorcyclist at the end of the straight section. So for calculating the speed, you can write acceleration into the change in time, AT. Speed is equal to acceleration to time. Here the acceleration is given as, is accelerating at 7.2 meter per second square. And the time is given as, for reaching the straight path, completing that straight path, the time is 5.3 seconds. So just we can multiply it. That is 7.2 into 5.3 meter by second into second. Meter by second square into second. So the speed will be, after multiplying, you'll be getting 38 meter per second. The speed can be written as 38 meter per second. Calculate the resultant force on the motorcyclist and the motorcycle on the straight section of the track. So force is equal to mass into acceleration. Mass is given as, we have seen here, it is 240 kilogram. 240 kilogram into acceleration. Acceleration is given as 7.2 meter per second square. So in that straight section, the motorcyclist is traveling in 7.2 meter per second square. Just we can multiply it. You'll be getting the answer 1728 kilogram meter per second square or Newton. So the answer is approximately, rounding to significant figures, 1700 Newton. At the end of the section, the track remains horizontal but bends to the right. So we have seen there, he is traveling in the straight line, then bending towards right. When the motorcyclist reaches the bend, she travels around the bend in a circular path at a constant speed. So here she is traveling in a circular path with a constant speed. So here velocity is a vector quantity. So state how a vector differs from scalar. So vector quantity is there, scalar quantity is there. In the case of vector, it will be having both direction and magnitude. Direction and magnitude will be there in the case of vector. Scalar does not have any direction. Direction will not be there for a scalar quantity. Describe what happens to the velocity of motorcyclist as she travels around the bend. As already we are told, velocity, it is a vector quantity. So direction changes, he is taking a bend. So the direction is being changed. So the velocity also will change. Explain why there must be a resultant force on the motorcyclist as she travels around the bend. So when she is accelerating around the bend, the direction will change. And there will be a change in velocity. Velocity is changed. As velocity changes, we need to calculate the resultant force also. Resultant force needs to be calculated as there is a change in velocity. Question number 3. A rubber balloon is inflated with helium and sealed so that no helium escapes. So rubber balloon will be there. Inside helium is there. It is sealed balloon. The balloon is positioned below the ceiling in a row. Heaters are switched on. So when you are switching on the heaters, the temperature of the room increases. When the heaters are first switched on, the temperature of the air immediately below the ceiling increases quickly. So immediately below the ceiling, the temperature increases quickly. Then the temperature of the air in the rest of the room. Explain why this is happening. So here in the room, cooler air is there and warmer air is there. So as heater is switched on, warmer air will be there, cooler air will be there. Normally cooler air, it will be more denser. Density will be more in the case of cooler air. And density will be less in the case of warmer air. So as it is less dense, warmer air is less dense, it will move upwards. The density of warmer air is less than the cooler air. So the warmer air rises to the ceiling, displacing the cooler air. The temperature of helium in the balloon increases, and as the rubber stretches, the volume occupied by the helium increases. So it will start stretching. State what happens to the motion of the helium particles as the temperature rises. So temperature rises, it is moving further forward, that is, it will move faster and the speed will increase. The helium particles will be moving faster and the speed will increase. As the rubber stretches and the volume of the helium increases, the pressure of the helium remains constant. Explain in terms of the particles of helium how the pressure of the helium is constant. So here pressure is remaining constant. Pressure means that is force by area. Pressure can be written as force divided by area. Here we can see the volume has been increased. Volume increases means that surface area is being increased. And as temperature rises, temperature is more. The particle collides harder and more force. There is a greater momentum or more force will be there. Particles collides and force is more. Here area is more. We can see P is equal to F by A. Here force is increasing parallelly. Area also increases. So both it is getting increased. That is the effect of larger area cancels the effect of larger force. That is effect of force and this effect of area. Both are more. It will cancel each other. So as it is cancelling each other, the pressure will be constant. Question number 4. A student investigates the efficiency of a filament lamp. Figure 4.1 shows the filament lamp with its glass bulb immersed in the water beaker. We can see one lamp is there, water in the beaker is there, one thermometer is kept. Reading on the thermometer in the water is 19 degree. So initially the first reading is 19 degrees Celsius. Only the glass of the lamp is in contact with water and remaining part it is insulated. Electrical connections are completely insulated. The lamp is switched on. So once the lamp is switched on, the temperature of the water has rise to 21.5 degrees Celsius. So here there is a change in temperature. At the end, the mass of the water in the beaker is 600 gram. So mass is 600 gram and the specific heat capacity of the water, that is C, that is 4200 joule per kilogram degree Celsius. Show that the increase in internal energy of the water is 6300 joules. So we need to find the increase in internal energy. So increase in internal energy can be written as mass into specific heat capacity into change in temperature. So mass is given as 600 gram, but our specific heat capacity is in kilogram. Here M is equal to 600 grams. But C is given as 4200 joules per kilogram degree Celsius. So this needs to be converted to kilogram. That is divided by 1000. So we can write it as 0.6 kilogram. And what is the change in temperature? That is 21.5 degrees Celsius minus 19 degrees Celsius. So it is 2.5 degrees Celsius. Just we can substitute the values here. M is 0.6 into 4200 into 2.5. Just multiply. We'll be getting the answer as 6300 joules. Hence it is proven. In the experiment, the lamp is switched on for 500 seconds. So here time is given as 500 seconds. The power supplied to the filament lamp is 13 volt and power is given as 13 watt. The useful energy from the lamp is transferred as light. And the energy that increases the temperature of the water is wasted energy. That is thermal wastage. Determine the maximum possible efficiency of the lamp. So we need to find the efficiency of the lamp. Efficiency can be written as the output energy we got by input energy into 100. So what is your output energy? So here output energy that can be written as the total energy. Total energy it is given as to find the total energy for 500 seconds. So E can be written as P into T. So here P is 13 watt into time is 500 seconds. So after multiplying, we'll be getting the answer 6,500 joules. So this is the energy for 500 seconds. So for finding the output energy, we need total energy minus energy dissipated as heat by input energy into 100. So energy dissipated as heat. So that is increasing the internal energy of water. The heating of water that is 6,300. So it is total energy is 6,500 minus energy dissipated as heat that is used for heating the water that is 6,300 by the total energy is 6,500 into 100. That can be written as 200 into 100 that is sorry, 20,000 divided by 6,500. You will be getting the answer 3.07. That can be written as 3.1 percentage. The efficiency of the lamp is less than the value determined. Suggest one reason for that. So here the thermal energy is transferred from water to air. Some energy is dissipated as heat, that is for heating the water, and this thermal energy is transferred from the water to air. Question number 5. Figure 5.1 shows a block ABCD made of glass that has a refractive index of 1.5. The block has curved side AB and 3 straight side BC. We can see here one curved side is there. This one, that is AB. Then BC is there. CD is there. DA is there. Straight sides. There are right angles at C and D. So here the angle is right angle. The curved side AB is 1/4 of the circumference of the circle which has center at P. So this AP or BP can be the radius. It is a quarter of a circle. A ray of monochromatic light enters the block through the curved side AB. So the ray is passing through this curved side and strikes the side BC at P. Some light emerges into the air and some is reflected. So it is incident and some it is reflected and some it is emerges to the air. State what is meant by monochromatic light. Monochromatic light means light of single frequency or single wavelength or a single color. So I'm writing here single frequency. It can be either single frequency, single wavelength or single color. Explain why the ray of light does not change direction when it enters the block through side AB. Here the ray is incident along the normal. It is along the normal and the angle of incidence and angle of refraction it is 0 or there is no angle of incidence and angle of refraction. As the ray is incident along the normal, there is no angle of incidence and refraction. Or we can tell this is the curved path and it is on the same as normal or it is hitting at 90-degree angles. Show that the critical angle C for the refractive of the glass of refractive index 1.5 is 42 degree. Critical angle can be written as C equals sine inverse 1 by refractive index. So that can be written as sine inverse 1 divided by 1.5. Sine inverse of 1 divided by 1.5 means 0.666. So we can find the answer. That is 0.666. Sine inverse. That is 41.8 degree. The answer is 41.8 degree. It can be rounded as 42 degrees. Figure 5.1 shows that the angle between the ray of light and line AP is theta, where line AP is at right angles to the side BC. Angle theta increases to 45 degree. State and explain what happens to the light that strikes at P. So here we can see this is theta and the critical angle is 42 degrees. Here, the angle of incidence is greater than the critical angle. Angle of incidence is greater than the critical angle. This is 45 degree and this is 42 degree. So whenever this angle of incidence is greater than critical angle, reflection will occur and the light will be getting reflected. When theta equals 45 degree, the reflected light strikes side CD. Describe what happens when this reflected light strikes CD. So here the theta is 45. It is striking this point and the reflected light, it is being struck at CD. Then all light is reflected at 90 degree. So when it is striking this CD, the light will get reflected like this again. Sorry. That means it will at 90 degree, it will get reflected and these two lines, it will be in parallel with the starting. These two lines will be parallel. So all light is reflected at 90 degree to the incident ray and it will be parallel to the original ray. Question number 6. A mobile phone network uses microwave frequency 1.9 into 10 raised to 9 Hertz to transmit and receive signals. The speed of microwave in air is 3 into 10 raised to 8 meter per second. Calculate the wavelength. So V is equal to F lambda. We need to calculate lambda. That is the wavelength. Lambda is equal to speed by frequency. Speed, it is given as 3 into 10 raised to 8 meter per second. And frequency is given as 1.9 into 10 raised to 9 Hertz. So 3 by 1.9 means that is 1.57 into this 10 raised to 9 will go on the top, 10 raised to 8 minus 9. That can be written as 1.57 into 10 raised to minus 1. So it is 0.157 meter. Rounding off, we can write it as 0.16 meter. State 2 reasons why microwaves are used for mobile phones. So it can penetrate walls. Microwaves can penetrate some walls. And it need short antennas. A mobile phone network uses digital signals to communicate with the phone. Describe with the aid of a diagram how a digital signal differs from an analog signal. So in the case of digital signal, it will be having only two values. With respect to time we are drawing, it will be just having zeros and ones. Only zeros and ones will be there. And in the case of analog, with respect to time, for example, I am taking sine wave. It will be varying with respect to time. The value at each instant will be different in the case of analog wave. You can draw some symbol wave. This is also analog wave. So it will vary with respect to time. State 2 advantages of using signals that rather than analog signals. We prefer digital signals because of its faster data transmission rate and noise rejection is easy. Noise can be removed easily from the signals. Figure 7.1 shows a circuit that contains a battery. Here a battery is there, a switch is there, voltmeter is there, 340 ohm resistors are there. So 340 ohm resistors, that is here R1 is equal to R2 is equal to R3 is equal to 40 ohm. All resistor values are same. The switch is open. The resistor R1 and R2 forms a potential divider. So here switch is in the open condition. R1 and R2 forms a potential divider circuit. That means here one supply voltage is there. Two resistive networks R1, R2. Voltmeter is being connected across R1. This is R1, this is R2. So describe what is meant by a potential divider. So a potential divider splits the voltage between the resistors. Suppose you are giving here 10 volt, for example, and these both resistors are of same value. This is 2 ohm and this is also 2 ohm. So this will be equally split. Here it will get 5 volt, here also will be getting 5 volt. The voltage will be splitting depending on the resistance value. So a potential divider split the voltage between the resistors connected in series to the power source, and the voltage will be voltage generated across these resistors or the components will be in proportional to the resistor value. If it is same, it is equally divided. If it is not same, it will be in proportional with the resistor value. The reading on the voltmeter is 7.5 volt. So now we got a reading as 7.5 volt. Calculate the electromotive force of battery. So we need to find the EMF of the battery. So by potential divider equation, V out is equal to V input into R1 divided by R1 plus R2. Here R1 is equal to R2 is equal to R, same value. So this time substituting V input into R by R plus R, that is 2R. So this R and this R will get cancelled. It will be equal to V input by 2. We need to find the V input voltage. So V input can be written as 2 into V out. That is equal to 2 into 7.5 volt will be equal to 15 volt. In this method, we can find or just we can calculate both value resistor, it is same. So across R1 it is 7.5. So same drop will be across R2 also. So the total voltage will be 7.5 plus 7.5, that is 15 volt. Next, the switch is closed. So here the switch is being closed. Calculate the resistance of the complete circuit. So for same value resistance, equivalent resistance, if you are connecting two resistors in series, the equivalent resistance will be 2 into R. If you are connecting two resistors in parallel, the equivalent resistance will be R by 2. So the value of the resistor here, it is 40 ohm. This also 40 ohm. This also 40 ohm. These two are coming in parallel. So the equivalent resistance will be R equivalent will be equal to 40 by 2, that is 20 ohm. Now we can simplify the circuit as this is 40 ohm and equivalent of these two, that is 20 ohm. So these two are coming in series. So the total resistance will be, as it is in series, it is R1 plus R2. That is 40 plus 20, that is 60 ohm. Calculate the reading of the voltmeter when the switch is in the closed position. Here we can again use potential divider equation. V out is equal to V input into R1 by, here we need to calculate the equivalent resistance. So these two, the equivalent resistance we need to put, that is R equivalent plus R1. So we can write it as V input voltage. We already found out, that is 15 volt into R1 value is 40 and R equivalent, the total resistance R total, it is 60. So can cancel it. Times this is 3. This will be 5. 5 into 2, that is 10 volt. So we'll be getting the answer as 10 volt. Question number 8. The electricity supplied to a town is transmitted using high voltage cable. A transformer in the town has soft iron core. Explain the principle of operation of simple iron core transformer. So transformer will be having primary winding, secondary coil. So when you're applying an AC voltage, AC input voltage to primary, it generates a change in magnetic field. The changing magnetic field will be getting transferred to the secondary coil through the iron core. That means the iron core transfers magnetic field to secondary coil, and the change in magnetic field induces an EMF in the secondary coil. Next, the transformer steps the supply voltage from 2,20,000 voltage to 33,000 voltage. So here the voltage is getting stepped down. This is the input primary voltage and this is the secondary voltage. There are 450 turns in the secondary coil. That is NS. Number of turns in secondary is 450. Calculate the number of turns on the primary coil. The equation is Vp by Vs. Voltage in primary by voltage in secondary is equal to number of turns in primary by number of turns in secondary. We need to find the number of turns in primary. So NP can be written as, this will go on the numerator part, that is Vp into Ns by Vs. So voltage in primary, it is 2,20,000 into number of turns in secondary, that is 450 by voltage in secondaries 33,000 . So we can cancel these. 11, it is 3 times. This one will be 20 times. This can be cancelled like this. 1, 1, 5, 50. So by multiplying these two, 2 into 15, that is 30, 0, 0. That is 3,000. So number of turns in the primary will be 3,000. Next, the electrical power transferred to the transformer by the high voltage cable is 77 megawatt. Calculate the current in the primary coil. So P is power is equal to 77 megawatt. That is P can be written as I into V. We need to find the current, that is current in primary. So I can be written as P by V. So power here it is 77 megawatt. Mega means into 10 raised to 6 by voltage in the primary. These are all primary voltages and current. So primary voltage it is 2,20,000. So we can divide this one and write it as 0.00035 into 10 raised to 6. So 10 raised to 6, we can multiply it 3 points. So it is 350 amps. So the current in the primary coil, it is 350 amps. Question number 9. The figure represents all the particles in a neutral atom of a radioactive isotope X1. So here we can see 1, 2, 3, 4, 5. 5 electrons in this orbit. And the gray particle, it is neutrons. So 1, 2, 3, 4, 5, 6, 7. So total 7 neutrons. And 1, 2, 3, 4, 5. 5 protons. Determine the number of neutrons in this atom and explain how the answer is obtained. So already we have calculated, that is it is 7. Explanation, it is gray dots are neutrons. Otherwise, we can find it as the total number of electrons, it is 5. And the total number of particles inside the nucleus, that is 12. Total 12 particles are there inside the nucleus, that is its mass number. And we can subtract this 12 minus 5. We'll be getting the answer as 7. In this method also, we can find it. The isotope X1 is a beta emitter that decays to a stable isotope X2. Describe how a nucleus X2 differs from nucleus X1. So here X1, it is a beta emitter. It decays to X2. So when it is decaying, this neutron will be changed to proton, then one electron and one anti-neutrino. That means the neutron in the nucleus that emits proton, electron and anti-neutrino. So the new isotope, stable isotope, this X2, it will have one extra proton and one extra electron. So here one more proton will be there. One more electron also will be there. One more electron is also there. This means that atomic number of the nucleus increased by 1 unit while the mass number remains the same. So atomic number has been changed to increase by 1 unit, but mass number remains same because one neutron is converted to proton. So it is getting exchanged. Mass number is remaining same and atomic number is increased by 1. Suggest why isotope X2 is stable whereas X1 is not stable. X1 is actually unstable due to too many neutrons. too many neutrons in the nucleus compared to the number of protons. Comparing the number of protons, the amount of neutrons it is more. And when you're taking X2, it is stable because it attains a more balanced neutron to proton ratio. In the case of X2, balanced neutron to proton ratio is achieved. That's why it's more stable. The half-life of X1 is approximately 20 milliseconds. Define the term half-life. So here half-life refers to the time it takes for half of the radioactive nuclei in the sample to undergo radioactive decay. Suggest one reason why isotopes with very short half-lives are especially hazardous. Because they emit the radiation at a higher rate. In a short span of time, the radiation emitted will be more. That's why it is more hazardous. Question number 10. Pluto is a dwarf planet. The figure shows the direction of motion of Pluto and it follows an elliptical orbit around the Sun. Point X is the point orbit close to Sun. So one point is close to Sun and Y is far away from the Sun. Here the orbital speed of Pluto varies as it orbits the Sun. So we have marked point X and Y. Describe how the speed of Pluto varies as it moves from X to Y and then back to X. So when it is moving from X to Y, here we can see X is nearer to Sun and when it is moving in this path is far away, the speed decreases. And when it is moving from Y to X, the reverse path that is Y to X. In this path, it is moving. It is nearing the Sun. Just opposite. That is speed increases. Explain in terms of energy transfer why the speed of Pluto varies in this way. So here there is a transfer of gravitational potential energy and kinetic energy. Here, the interchange between this gravitational potential and kinetic energy causes the energy transfer. As it is closest to Sun, when the point is closest to Sun, the Pluto will be having high kinetic energy. And that means at point X, kinetic energy will be more. And at point Y, gravitational potential energy will be more. As kinetic energy is more, it will be faster. Speed will be more. Here, potential energy is more means speed will reduce. So here, Pluto's speed decreases as it moves away from the Sun, converting some of its kinetic energy into potential energy. When it is moving away from the Sun, this kinetic energy is transferred to potential energy, so the speed is decreasing. The average temperature on the surface of Pluto is 43 Kelvin. Convert this temperature to degrees Celsius. So we can convert by 43 Kelvin minus 273. So it will be minus 230 degrees Celsius. The Pluto has white surface and black surface. As Pluto rotates, the white surface alternatively faces towards and away from the sun. Explain how this affects the temperature of Pluto as it rotates on its own axis. So here white surface, it is a bad absorber and a bad emitter. It is a bad absorber, same time it is a bad emitter of IR radiations. While we are taking black surface, it is a good absorber and emitter of IR radiation. So while facing the sun, the temperature rise will be more in the case of black surface and less in the case of white surface. And when it is away from the sun, the temperature fall. How the temperature is falling? The temperature fall will be more in the case of black surface and there will be less variation in the case of white surface. That is, black, it is a good absorber and emitter. So when facing the sun, the temperature increase will be more. When away from the sun, the temperature decrease will be more. In the case of white, just reverse will happen. It is a bad absorber of and bad emitter. So while facing the sun, the temperature rise will be less. While facing away from the sun, the temperature fall will be less. There will be less variation in the case of white surface. Thank you all. We'll see in the next video.